Good day, weather technology students. In this video, we're going to talk about how we can do some simple calculations with our gridded output and add it to our data set so we could plot it. So let's go ahead and open up a terminal window. And we're going to first get into our working directory, our MET130 directory. And then we're going to go ahead and copy over a file. And we're going to start with this idea of thickness and calculating thickness. And so what we need to do is we need to copy over a file from Valpo_courses again. So CP, go back a directory to get to Valpo_courses, WeatherTech, notebooks. I'm using tab completion here to help me out. And then model_calculations_thickness.ipynb is the file we want to go ahead and copy over. So go ahead and get it copied over, and if in your left-hand window here you're in your MET130 directory, then you should see model calculations thickness there, and then you can go ahead and give that an open. So we'll go ahead and walk through this. This notebook actually contains two different types of simple calculation for the most part, and so we'll walk through both. And so one thing moving forward that you're going to want to do with some of these notebooks is that we do more in a notebook than we need. And so what you're going to want to do for things like homework assignments or your project is to take what we've done and excise it into new notebooks so that then you can utilize the pieces of it. So again, here we're going to start with the same classic imports that we have used throughout most of our declarative section here. Whoops, what did Kevin forget to do? He forgot to change his kernel. Change the kernel. There, it's active now, so we can go ahead and start. Get all of that brought in. Here again, this is going to should be familiar. We are using a particular date with their date time function, so March 15, 2021 at 0 UTC. Pulling it from our friends at Unidata, their thread server there, subsetting to just over the US, and then setting up our plot time as just the current F00 hour currently. So we can go ahead and run that and gain access to that file. And so we have to do that, and now we've got all of our data, our model output, stored in the variable name DS. And so what we want to do is we want to add a new variable to that. And so with Python, this actually is relatively simple, although it's going to look a bit more complicated with all this code that we have. And so we're doing a couple of things here. The first thing we're doing is we're pulling out just the 500 millibar geopotential heights and just the 1000 millibar geopotential heights from our dataset DS. And so how are we doing that? Well, we're using the selection method, or .sel, from Xarray to help us out. And so we are subsetting by time, and we are subsetting by vertical level. And so the way we're doing this is we're using something within our MetPy module called an accessor. Don't really need to know that, but it's the case. So here, ds dot, the name of our variable that we're wanting to subset, .metpy.select, which is then going to allow us to use the generic name of time and vertical for our time coordinate and our vertical level. We're setting time equal to the plot time we set up here in our previous cell. And the vertical level here, we're giving a unit value, right? 500 units HPA. So we're giving that level with units. Then what we're doing is then we are quantifying this variable. So this is basically attaching the units from our data set to it, which is going to make our calculation go better and easier to store properly back in our data set. And so we do the same thing for 500 millibars and 4,000. And so when I originally created this, I had done it for 500, and then I copy and pasted and then just modified it for 1,000 millibars appropriately. So here we've pulled out and stored our data into different variables, so that then when I'm adding my calculation to my data set, I can now do so simply with a simpler looking line. And so to add a new variable to our data set, we first start off with the name of our data set variable, ds in this case, open square bracket, and then within quotes we give a unique name to this variable. And so I'm just calling this thickness. Maybe I could have called it thickness underscore 500 underscore 1000, right, to describe what thickness value it is. But here I just called it a generic thickness. And then I'm setting that variable in our data set equal to our now calculation. And so we're doing 500 heights minus 1000 millibar heights, which is our classic thickness variable here. Okay. And then I'm doing metpi.dequantify, which is going to take that, strip that units value off and put it as an attribute into our data set. And so if we go ahead and run this, it'll run pretty quick. And one of the reasons why we subset it by time is that we don't want to pull down all the times for the 500 millibar heights and all the time for our vertical levels, because then it's just going to take longer to process, especially if we're only looking to plot a single time. And so we can see now what this new variable looks like if we add in a cell, and we can do ds.thickness and get the information about our thickness values. And so we see we have only 61 latitudes, 96 longitudes since we're subset over the US, and we no longer have a time or a vertical dimension because we already subset for those previously. And we see that now we have our attributes as our units of meters. And so now when we want to go ahead and plot this, we're going to need to do a few changes to how we normally plot things. And so again, thickness here is going to be dominated by 500 millibar heights. And so we're going to use the same contour values as we do for 500 millibar geopotential heights for thickness. And so here we're just going to plot some contours of our thickness. So again, here we're feeding our ds variable where we added our thickness variable to. But now our level, since we already subset, we don't need to specify our level. So we say level equals none. Same thing for time. We already pre-subset our data, so we don't need our time variable. Our contours is going to be list range 0 to 10,000 by 60, just like our 500 millibar heights. But now we're going to color these in red, or color the contours in red, and make them dashed contours. And of course, add RC labels. In addition to our thickness contours, I'm going to add some geopotential height contours, which will be solid black lines, and then add that to our map with states, coastlines, and borders, have an appropriate title, and add both our contours, which are our thickness contours, and our geopotential heights to them, and then add that to our panel. So let's go ahead and see how this runs. And so there we go. Now we have our plot of 1,000 to 500 millibar thickness with our geopotential heights. And what we see is from March the 15th, 2021 at 0 UTC, we now have our thickness values plotted here. And we see colder or smaller thicknesses. Here's that 5,400 meter line. Where our troughs are, we see lower thickness values than where our ridging is, where we have higher thickness values. Again, they're not exactly aligned here, but there is a relationship. And that's because, of course, our 500 millibar heights are related to the temperature of our levels as well. So that's it for thickness, right? And we could do the common thing of now if we wanted to change what time we're going to do, we could say maybe excise this plot time here. If we're going to ultimately do a forecast, we're going to say days plus, let's go 72 hours into the future. And so we're going to re-subset our data, do our calculation, add that new variable to our data set. We'll see our thickness value should change there. And then if we go ahead and plot up our data, we're going to plot something in the future. So this was now March 18th at 2021. We see our trough has moved on a little bit, and our thickness has changed a little bit as a result. So again, we can take these examples and modify them for use in different ways. That's it for thickness and this video. We'll come back to this notebook in a future one to talk about how we can scale a variable easily using MetPy. That's it for this one. Thanks for watching.